This is the Math 3 review for Unit 5, just covering units or sections 1 through 6 in this particular review. Number 1, we're asked to simplify each radical expression, use absolute value symbols when needed. Basically, when we take the even root of a number, we need a positive result. And when we're working with variables, we gotta keep in mind that that variable can be positive or negative or 0, and so we just need to assume the variable's negative as you're working through these, and just keep in mind, use your absolute value when you need it. So in part A, square root of 9 is 3. The square root of c to the 4th is c squared. And the square root of d squared is d. Kind of. And then go back and just ask yourself, could any of these be negative? Well, 3's a positive number, so no worries about that one. C squared, whenever you square a number, you always get a positive result. So c squared is going to be positive, even if c itself is negative. D, we don't know. D could be negative, so we need to put the absolute value sign around the D. And that's our answer. For part B, want to take the square root. And things are not set up like they were in part A to take the square root. So I'm going to rewrite this a little bit differently. Make sure you have everything still, carry it with you. So that A is still on the outside. 27, if you break the number 27 down, 27 is 9 times 3, and 9 is 3 times 3. So we get 3 times 3 times 3. A to the 5th is A times A times A 5 times, and B to the 6 is B times B 6 times. That's what A to the 5th and A to the, or B to the 6th mean. Well, whenever you take 2 of the same number and multiply it together, you get a perfect square. 3 times 3 is 9. A times A is A squared. Again, A times A is A squared. So we're looking for perfect squares, and so we're just looking for pairs. And so we're going to keep going. Now, what's important to note here is this A that's out in front, we did not take the square root of. It was there to begin with. It could be positive or negative, and that's okay. We do not want to put an absolute value sign around something that was on the outside of a square root to start with. It's only the things that we are bringing out. Okay, so we're going to keep track of these things. So I'm going to use blue to represent that A that's out front already, and then I'm going to change the color to keep track of what we're taking the square root of. So 3 times 3 is 9. Square root of 9 is 3. So times 3 times A times A times B times B times B. So each pair that I circled in the previous step gave, I was able to take a square root of, and what was left, what we did not take the square root of, is 3A. Let's put some stuff together here. Again, I'm still going to keep this first A separate at first. And we have 3a squared b to the third square root of 3a. Now at some point we need to say, well, do we need an absolute value for any of that stuff that we pulled out of the square root? So the 3, again, we know is positive. A squared, anything that's squared is positive. But b cubed, if b were a negative number, and you cubed a negative number, we would get a negative result. So b cubed needs that absolute value around it. Okay. Last step is we still have that a out in front. We can multiply with the a squared. So our final answer is 3a to the third, absolute value b to the third, square root of 3a. Number 3. On 3, we're looking at the cube root this time. So 64 is 4 times 16. 16 is 4 times 4. And we can break those down to 2's if we would like. But we're looking for sets of 3 things. And and it's negative, so I could picture this as a negative 4 times negative 4 times negative 4. So I'm going to write that out. Negative 4 times negative 4 times negative 4. And then we have x to the third, which is x times x times x, and y to the 6. So whenever you multiply 3 of the same number together, you get a perfect cube. And so we're looking for perfect cubes to take the cube root of. And so we're looking at the sets of 3 here. When you take the cube root or an odd root of a number, you are allowed to have a negative result. So we don't use absolute value at all when we're taking the cube root. So the cube root of negative 4 times negative 4 times negative 4 is negative 4. The cube root of x times x times x is x. Cube root of y times y times y is y. And the cube root of y times y times y again is y. So nothing is left, so we don't need that cube root sign anymore. And all we have to do now is multiply the y times y, negative 4xy squared. That's our answer. Next one. 16 is 4 times 4. 4 is 2 times 2. So we get 2 times 2 times 2 times 2, x to the 4th. Y to the 9th. And we're looking at the cube root. Don't have to worry about absolute value at all. And we're looking for sets of 3. So we got 3 2's here with 1 left over, 3 x's with 1 left over, and then 3 sets of 3 y's. So when we take the cube root, we get 2x y times y times y. And then we're left with the cube root of 2x. And y times y times y is y cubed, so 2x y to the third times the cube root of 2x. Number 2, find all the real solutions of each equation. So here, to find the real solutions, we're going to take the cube root of both sides. So when we take the cube root, we get the cube root of x cubed is equal to the cube root of 8. Well, the cube root of x cubed is x, and the cube root of 8 is 2, because 8 is 2 times 2 times 2. Same idea with part B. We take the cube root of x cubed, take the cube root of negative 27. Cube root of x cubed is x. The cube root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Number 3, we're asked to multiply and simplify over the reals, if possible. And so this is the cube root of 9 times 9, which is the cube root of 3 times 3 times 3 times 3. And if we're looking for a perfect cube, you get a cube by multiplying the same number together 3 times. And so this is going to be 3 cube root of 3. Part B, here we have the square root of 8 times 6 times x squared times y squared. 8 is 2 times 2 times 2. 6 is 2 times 3. And I'm going to leave x squared and y squared. And 2 times 2 is a perfect square. 2 times 2 is a perfect square again. And x squared is a perfect square, and y squared is a perfect square. So when we take the square root, we get 2 times 2 times x times y, and we're left with the square root of 3. But when you take the square root, here's where we gotta wonder if we should use the absolute value or not. Well, 2 times 2 is positive 4. Don't need an absolute value around that. X could be a negative number, so we do need the absolute value of x. Y could also be a negative number, so we do need the absolute value of y. And then the square root of 3. Part C. When we multiply things together here, we get 2 times 3. We have x times x cubed, so that gives us 4 x's. And we have y to the 5th. We're taking the square root, so we're looking for pairs, because whenever you multiply a pair together, you get a perfect square. And so x times x is x squared. The square root of x squared is x. Again, x and y and y. And we're left with the square root of 2 times 3 times y. So that gives us x squared, y squared, square root of 6y. When you take the square root out, you got to worry about absolute value. Can x squared be negative? No, because whenever you square a number, positive or negative, you get a positive result. Same reasoning for y squared. So this is our answer. On part D, we have the negative and the 4 out in front, so when I multiply these together I get negative 4 cube root of 2 times 12. 2 and the 12 are on the inside. 12 is 2 times 6, so 2 times 6. 6 is 2 times 3. So 2 times 2 times 3 is my 12, and I had the 2 from the first cube root. And then we have an x cubed and an x to the 5th. So x cubed right here, x to the 5th, 5 more. So we end up with 8 x's. And then the first one had a y squared, so that's 2 of them, and then the next one had a y. So we're looking for sets of 3, because when you multiply 3 things together that are the same, you get a perfect cube. Don't have to worry about absolute value, because we're taking the cube root. And we're left with the cube root of 3x times x. Simplifying a little bit more, we get negative 8, negative 4 times 2, x squared, y, cube root of 3x squared. Number 4, we are asked to simplify each expression, rationalize all denominators, and assume all variables are positive in this case. Okay, so we don't have to worry about absolute value. So when you have a square root over a square root, so they have the same root, you are allowed to reduce. So just as you would with a regular fraction. So 5 over 10 is 1 over 2. So this is the square root of 1 over the square root of 2. Square root of 1 we know, but we need to rationalize the denominator, meaning we can't have a square root in the denominator. So the trick here is to multiply by something that gives you a perfect square. And 2 times 2 is a perfect square. And so we get the square root of 2 over the square root of 4. 4 is a perfect square, so this is the square root of 2 over 2. And the denominator now is a rational number, and everything is reduced. That's our final answer. Part B. We can't simplify the 2 and the 6 because the 6 is underneath the cube root sign, whereas the 2 is not. So what we're going to do here is try to get rid of, or try to rationalize the denominator. We're wanting to take the cube root, so I'm going to multiply by the cube root of 6 times 6, because I already have 1 6. If I multiply 6 times 6 times 6, I get a perfect cube that I can take the cube root of. So this gives us 2 cube root of 6 times 6 over the cube root of 6 times 6 times 6. Perfect cube here. So that's 2 cube root of 36 over 6. Now the 2 and the 6 can reduce. Leave this the cube root of 36. And 2 over 6 reduces to 1 over 3. We cannot divide the 36 by 3 because the 36 is underneath the cube root sign, whereas the 3 is not. Everything here is beneath the square root sign, and so we can simplify things that will simplify in the x to the 4th and the x squared. We can reduce, so the square root of 6x squared over the square root of 5y to the 5th. Well, we can take the square root of x squared, which is x, square root 6. Because we're assuming all the variables are positive, I don't have to use absolute value here, otherwise I would be needing that. And here we have 5 times y to the 5th, so y with 5 y's. So notice we already have some perfect squares here. We need everything to be a perfect square in order to rationalize the denominator. So we need another 5, and we need another y. So now we have x square root of 6 times 5 times y over square root of 5 times 5 times y 6 times. Because we had 5 from the first and 1 from this next, so now we have a pair of everything. We're able to get rid of that square root sign in the denominator, which is what we want to do. That's what we call rationalizing the denominator. So we get 5 times y times y times y, so 5y cubed. And we can't reduce anything. The 30 and the 5 can't look at those because one's underneath the square root, one's not. Same for the y's. Part D. We're to determine whether each expression is equivalent to 20x times, or square root of 20x times the square root of 10x cubed y to the 5th. Select yes or no for each expression. So what we can do here is multiply everything together. So if I multiply everything together here, I get square root of 20 times 10, which is 200. X times x to the 3rd, which is x to the 4th, and y to the 5th. So are any of these equal to that? So at a first glance, nothing looks exactly like that. So let's keep working through this. I'm going to get a few different representations. So this is also 2 times 100, x to the 4th, and then y to the 5th is y to the 4th times y. Can't take the square root of 2, but we can take the square root of 100, that's 10. Square root of x to the 4th is x squared. Square root of y to the 4th is y squared. And then we're left with the square root of 2y. So there's some options. Notice this last option here. I'll highlight it. Although it looks a little bit different, it is the same thing as what we have here. And so I'd mark yes for that one. The one before it is clearly not the same. If you just look at the y squared, we have a y squared on the outside, but we don't have a y on the inside. And we know we should, so we're going to say no to that one. So option 1, 2, 3, and 4, we did 3 and 4. On option 2, so if we just took the square root of x, we can see from this one we'd have x squared times the square root of 200 y to the 5th. And the only difference is they have an absolute value of x squared, but the absolute value of x squared is the same thing as x squared. So that's really the same piece here. So that one matches this one here. And our first case, let's do a little work on. They have 2 times the square root of 5x times y times the square root of 10x cubed y cubed. So that would be 2y times the square root of 50 x to the 4th y cubed. Uh, 50 is 2 times 25. So that, and y cubed is y squared times y. So if we have a 2y already, take the square root of 25, that's times 5. Take the square root of y squared, that's another y. Square root of x to the 4th is x squared. You're just going through this, you're left with 2y. And when you multiply that together, you do end up here. So it's the same thing, so we're going to say yes to that. So number 5, when you add things, you can only add like terms. And in this case, on part A, they both have a root 5. And so what's really happening here is we're factoring out a square root of 5. So this is the square root of 5 times 10 plus 2. But instead of writing the square root of 5 first, we usually put it second. And 10 plus 2 is 12, and so we get 12 square root of 5. In the second one, same idea. We can factor out the square root of 11x. So we get 5 minus 8 times the square root of 11x by factoring out the greatest common factor. And then 5 minus 8 is negative 3. On C, there's nothing we can factor out. But we can try to simplify square root of 12. The square root of 12 is the square root of 3 times 4, or 3 times 2 times 2, and 2 times 2 is a perfect square. So I'm going to rewrite this as 5 root 3 plus 2 root 3 Now we can factor out the square root of 3. I'm going to factor it on the right side though. So we get 5 plus 2 times the square root of 3. 5 plus 2 is 7. And we get 7 root 3. For part D, we're working with a cube root. There's nothing to combine. We can't factor out anything. So we can try to simplify. 81 is 9 times 9. So I'm going to rewrite some of these. This is 5 times the cube root of 9 times 9, or 9 is 3 times 3. So 3 times 3 times 3 times 3 is 81, minus 3 times the cube root of 54. 54 is 9 times 6. So 3 times 3 times 3 times 2. Just double check that. 3 times 3 is your 9. 3 times 2 is 6. 54. And so cube root of 3 times 3 times 3, which is a perfect cube, we can get this working. So first one is 5 times 3 times the cube root of 3, minus 3 times 3 times the cube root of 2. That's 15 cube root of 3, minus 9 cube root of 2. And there's nothing. I mean, you could factor out something from the 15 and 9, but that's not too useful to us, so we're just going to leave it as is. Part E. Four times 216 square root of 216. So let's break down the 216. That's 2 times 108. 108 is 2 times 54. 54 is 6 times 9. 6 is 3 times 3. 3 times 2. 9 is 3 times 3. And 54 again, could break that down, 6 times 9. So we're going to rewrite this as 4 square root 216. We have 2 times 2 times 2 times 3 times 3 times 3, w squared, so times w, plus 3 times 2 times 3 times 3 times 3 times w times w. Pairs of factors create perfect squares. So take the square root of those perfect squares, 4 times 2 times 3 and times w. And then we're left with the square root of 2 times 3 plus, we already had a 3 out, times 3 times w times the square root of 2 times 3. Simplify a bit further, we get 4 times 2 is 8, times 3 is 24w, square root of 6, plus 9w, square root of 6. Both terms have a square root of 6, so we could factor the square root of 6 out. I'm going to factor it to the right side though, so we get 24w plus 9w times the square root of 6. 24 plus 9. Actually, I didn't do anything wrong, but I'm going to rewrite. I'm going to factor out a w square root of 6. So we get 24 plus 9 times w square root 6. And 24 plus 9 is 33. F, we're asked to determine whether the expression is equivalent or not to square root of 58. Sorry, 50 plus the square root of 8. Well, square root of 50 is, 50 is 2 times 5 times 5. 8 is 2 times 2 times 2. So the first one is 5 root 2. Second one is 2 root 2. If you factor out a root 2, and you can add the 5 and 2, you end up with 7 root 2. So yes on the last one, because that's 7 root 2. 7 times the square root of 2 is not 9, so no on the second to last one. Yes on the second one, because that matches my 5 root 2 plus 2 root 2. And square root of 58, well, if we look at the square root of 58, 58 is 2 times 29. And so there's really, you can't simplify square root of 58. That is in its simplest form, whereas what we're working with simplifies to 7 root 2. And so that alone tells us it's not the same thing. And so we're just going to say no. There's a couple other ways to look at it, but I think this is all I'm going to say for that one. 6, we're going to multiply. So don't forget to distribute. 3 times 3 is 9. 3 times negative 5 is negative 3 root 5. I get another, this time a positive 3 root 5. And then a negative square root of 25. Well, negative 3 root 5 plus 3 root 5 is 0. And so we're left with 9 minus 5. I'm getting the 5 because the square root of 25 is 5. And 9 minus 5 is 4. B, careful. What you don't want to do here is square the 2 and get 4, and square the square root of 5 and get 5, and go 4 minus 5 is negative 1. You would be wrong by doing that. So what you need to do is rewrite this as 2 minus root 5 times another 2 minus root 5, and distribute. 2 times 2 is 4. 2 times negative root 5 is negative 2 root 5. Another negative 2 root 5. And then a positive square root 25, which is the same thing as positive 5. So 4 plus 5 gives us 9. And negative 2 root 5 and negative 2 root 5 is negative 4 root 5. Part C. 1 times 5 is 5. 1 times root 2 is square root 2. 5 times square root of 98, and then square root of 2 times 98. As is, we can add nothing. We have no like terms, but let's see if we can simplify a bit further. 98 is 2 times 49. 49 is 7 times 7. And let me take another step on this one. So, rewriting this, we have 5 plus the square root of 2 plus 5 times the square root of 2 times 7 plus the square root of 2 times 7 which is equal to 5 plus the square root of 2 plus, I'm going to take the square root of 7 times 7, so that's 5 times 7 square root 2. And I'm going to take the square root of 2 times 2 and 7 times 7 and get 2 times 7. So now we have 5 plus square root 2 plus 35 square root 2 plus 14. 5 plus 14 is 19. Square root of 2 plus 35 square root of 2 is 36 square root of 2. And that's our answer. Part D. In order to rationalize our denominator, we're going to multiply by the conjugate, which is 1 minus square root of 2. And whatever you multiply the denominator by, you multiply the numerator by, which really is equivalent to multiplying our fraction by 1. When we do that, don't forget to distribute, and you get 5 minus 5 root 2 over, distribute the 1, you get 1 minus root 2. Distribute the positive root 2, you get positive root 2 minus root 4. In the numerator, we can factor out a 5, and we're left with 5 times 1 minus root 2, if we wanted to, which ends up back to where we were, or we could leave it as is. In the denominator, we have square root of 4, don't forget, is 2, so you have 1 minus 2, which is a negative 1, and then the negative root 2 and the positive root 2 cancel out. And when you divide by negative 1, you get a negative 5 times 1 minus root 2. Or you could write negative 5 plus root 2. I'm okay with either. For part E, we're going to do the same type of thing. Multiply by the conjugate of the denominator, which would be 3 root 8 plus 2. When you distribute, in the numerator we get 2 times 3 root 8, which is 6 root 8. And 2 times 2 is 4. Root 8 times 3 root 8 is 3 square root of 64. And root 8 times 2 is 2 root 8. In the denominator, distribute, you get 9 root 64 plus 6 root 8 minus 6 root 8 minus 4. Square root of 64, don't forget, is 8. Okay, so clean this up a little bit. In the numerator, 6 root 8 and 2 root 8 is 8 root 8 plus 4 plus 3 times 8, which is 24. In the denominator, we get 9 times 8, which is 72. 6 root 8 minus 6 root 8 is 0, so minus 4. 4 times 24 is 28. 72 minus 4 is 68. We can now simplify. 8 is 2 times 2 times 2. So, first of all, I'm going to do two things at once here. So 28, 8, and 68 are all divisible by 4. 28 divided by 4 is 7. 8 divided by 4 is 2. 8, I'm going to just break that 8 down to 2 times 2 times 2. And then don't forget what we're doing, dividing by 4. 68 divided by 4 is 17. And then we can simplify further. This is 7 plus 2 times 2 root 2 over 17, or 7 plus 4 root 2 over 17 is our final answer. Number 7, write each expression in simplest form. Assume all variables represent positive real numbers. Means we don't need absolute value here. So here we have 27 to the 1/3 power times x to the 9th to the 1/3 power. 27 to the 1/3 power means the cube root of 27. And x to the 9th to the 1/3, you multiply the exponents. You multiply 9 times 1/3. You can think of 9 as a fraction, 9 over 1, and you end up with 9 over 3. So this is x to the 9 over 3 power. The cube root of 27 is 3, and this is x to the 9 divided by 3 is 3, so x cubed. The next one, we're multiplying. 4 times 3 is 12. And when you multiply variables, you add their exponents. So it's going to be 2/5 plus 3/10. When you add fractions, you need a common denominator. So this is 12x to the 4/10 plus 3/10, which is 12x to the 7/10 power. Part C, I'm going to first reduce the fraction. 2 over 128 is 1x to the 6 over 64, y to the 15th. And now we're going to raise each piece to the 2/3 power. So we have x to the 6 to the 2/3 power. We have 64 to the 2/3 power, and we have y to the 15th to the 2/3 power. On the x to the 6 to the 2/3 power, you multiply the 6 and the 2/3 together and get 12 over 3. 64. This means the cube root of 64 squared. That's what the 2/3 power means in that context. And then y to the, I'm going to multiply 15 times 2/3 and get 30 over 3. 12 over 3 is 4. Cube root of 64 is 4. And 30 over 3 is 10. And then 4 squared is 16. So x to the 4th over 16 y to the 10th is what we're after. 8 we're solving. Get your square root by itself first. To get rid of the square root, you square both sides of the equation. And you get 2x plus 3 equals 25. Subtract 3 and divide by 2. X equals 11 is our answer. It's not a bad idea to plug that back in and check to make sure everything worked out fine, and when you do, it does. On B, I'm going to divide by 2. And then I'm going to raise both sides to the 4/3 power. The reason I'm doing that is because when you multiply reciprocals, when I multiply 3/4 and 4/3, I get 12 over 12. So this is x minus 2 to the power of 12 over 12. And 8, or the cube root of 8 to the 4th power. 12 over 12 is just 1, so this is x minus 2 to the power of 1 is equal to, cube root of 8 is 2 to the 4th power. X minus 2, anything to the power of 1 is itself, so it's just x minus 2 is equal to 16. Add 2 to both sides, and you get x is equal to 18. Number 9, part A. I'm going to square both sides to get rid of the square root. So we end up with 2x equals 3 squared times x plus 5. 3 squared is 9, so this is 2x equals 9x plus 45, distributing that 9 to both terms. Subtract, and you get negative 7x is equal to 45, and then x is equal to negative 45 over 7. There is an issue with this problem, because if you plug that back into the, say, the square root of 2x, that would make it the square root of 2 times a negative 45 over 7, and you can't take the square root of a negative number and get a real answer, and so we're getting some things that don't work out too well for us here, and so we're going to throw that out. It's what we call an extraneous solution, and so there's actually no solution to this problem. Part B, we're going to square both sides to get started here. The first one, when you square it, it gets rid of the square root. We get 1 minus x. The second part, when you square it, you're going to have to distribute everything. And we get 1 minus x is equal to x squared plus x plus x plus 1. Or 1 minus x is equal to x squared plus 2x plus 1. Still trying to solve for x. Because I have an x squared, I'm going to try getting the left side equal to 0. I'm going to do that by adding x to both sides and subtracting 1 from both sides. And I get 0 is equal to x squared plus 3x. Again, I added x to both sides, and I subtracted 1 from both sides. And then I'm going to factor, and then set each factor equal to 0, and solve for x. And I get two answers, x equals -3 and x equals 0. Go back to the original problem, check to make sure they work. If x is 0, we get the square root of 1 minus 0 is equal to 0 plus 1, which is true, and so we keep that answer. If x is -3, we get the square root of 1 minus -3 is equal to -3 plus 1. That's the square root of 4 is equal to -2. That's false. And so we need to throw that answer out. That's again what we call an extraneous solution. The only way to know we have one is to plug it back into the original problem and see if it makes sense or not. And that's our last problem on the first part of our review from section 1 to section 6.